The most disturbing possibility in physics is not that the universe is strange. It is that the universe may not be fully there when no one is looking. And there is a second possibility, stranger than the first. The looking might not be yours. There is a chair in a dark room tonight. A room with no one in it. The lights off. The door closed. Common sense says the chair is there, waiting, solid, patient in the dark the same way it sat in the light. Common sense has been wrong before, and what the most accurate theory human beings have ever written quietly suggests, carefully, tentatively, without settling the matter, is that the assumption of the chair sitting undisturbed in the empty dark may be the deepest, unexamined assumption in human thought. Not the most dramatic, not the most obvious, the deepest, the one so close to the eye that it goes invisible. This is not a provocation. It is a real problem, sitting at the center of the most successful science ever built. Quantum mechanics predicts the behavior of matter to better than 1 part in a billion. No experiment has contradicted it. The bridges stand, the machines work, the lasers that cut through steel, the transistors switching faster than the human heartbeat, the GPS signal correcting for the curvature of space-time. All of it rests on this theory, and the theory has never been wrong. The accuracy is not in dispute. The meaning is, begin where the trouble began. A particle, a single electron, sent through an apparatus one at a time, approaches a barrier with 2 narrow slits. Common sense says it goes through one or the other. It does not. When nothing records which slit the electron takes, the pattern that builds slowly on the far screen, one click, then another, over hours, is striped. Bands of arrival, bands of absence, the signature of a wave that passed through both openings at once and crossed itself on the other side. Not a wave of water, a wave of probability, of pure potential, belonging to a single particle moving alone through an empty room. The electron interferes with itself. This is not a metaphor. The screen shows it. The mathematics predicts it exactly. Something passed through both slits. The same something. There's something worth sitting with in that image, quietly. One electron, sent alone, without companions, through a chamber so still it might as well be the inside of a thought. No instruction, no path assigned. And yet the pattern it builds over hours, one soft click at a time, is one of the most orderly structures in nature. A striped interference signature, precise and repeating, the unmistakable mark of a wave that spread through both openings and folded back on itself. Something organized is emerging from something that looks, at each individual click, entirely random, not designed, not guided, just following the mathematics of possibility all the way to the end. You have felt the strange comfort of watching a pattern emerge from what seemed like noise. What emerges here is stranger. It is the pattern of something that was, at every moment, in 2 places at once. The single particle, moving as a wave, landing as a fact, and then the experiment that has unsettled a century of careful thinkers. Place a detector at the slits, any physical device that registers which path the electron actually took, and the striped pattern vanishes. The electron goes back to being an ordinary particle, through one slit, and only one, and the interference is gone, as though it was never there. The act of finding out changes what happens. The world snaps from a field of possibility into a single fact the moment the path is known. It is often said that the particle senses it is being observed, that some sensitivity to human attention reaches down into the quantum world and disturbs it. This is the popular version. It is wrong in the most important way. The detector, does not need to be a mind. It does not need to be conscious or even connected to a recording device anyone will ever read. What matters, the only thing that matters, is whether information about the path now exists in the world, anywhere, encoded in anything. When the which path record is present, even in a device that will never be checked, the interference is gone. When the record is erased before any trace can propagate, the interference returns. The disturbance is the information, not the watching, not the knowing. The existence, in any physical form, of a fact. This is a colder and stranger claim than the popular version, because it removes the need for you. Not your attention, not your mind. Just the world having registered something. Just the universe having made a mark. And yet, saying the disturbance is the information only moves the question, because the detector that records the information is itself made of atoms. It obeys the same equation as the electron. So does the wire carrying its signal, and the amplifier at the end of the wire, and the computer that logs the result, and the eye that reads the screen, and the nerve behind the eye, and the brain the nerve reports to. Everything is quantum, all the way up, and if everything is quantum, then the detector should also exist in a superposition, recorded both paths and neither, until something beyond it makes a measurement, and that thing should require measuring in turn. The chain extends. The strangeness does not stop at the slits. It propagates through every link. A man named John von Neumann, the mathematician who gave the machine you carry the logic at its core, set this out in full mathematical rigor in 1932. He proved something quietly devastating. The boundary between the observed system and the observer can be placed anywhere along the chain with identical predictions. At the particle, at the detector, at the scientist's retina, at the synapse. The mathematics does not care where the line is drawn. The theory does not say. It only says the line must exist somewhere because definite outcomes happen, because the pattern on the screen is real, because the chair either is or is not in the room. The line is real. Its location is undefined. The equations are silent on the one question you most want them to answer. This is the measurement problem. It has been open for 90 years. The equation that governs quantum systems, written by Erwin Schrödinger in 1926, still the most reliably correct equation in the history of science, is smooth and deterministic and continuous, and it never produces a single outcome. It only ever spreads possibility outward, one wave of and layered on another, forever. The mathematics describes a world of and, not a world of or, and yet the world you wake into is always or. One outcome, one slit, one fact. Somewhere between the equation and the experience, the and becomes or. Nothing in the formalism explains the crossing, the collapse of the wave, the snap from possibility to fact, is added by hand, bolted on, a rule that floats above the mathematics and refuses to follow from it. No one derived it. No one has. Anyone who tells you otherwise is selling something. So follow the chain. Follow it past the wire and the screen and the nerve and the synapse and every physical thing that can, in principle, be described by an equation. Follow it to the end. What is at the end is not more matter. It is the one node in the entire cascade that does not obey a wave equation, cannot be measured from outside, cannot be placed in superposition by any other system, because it is the place where the wave equation's predictions finally land, the place where the haze of and becomes the experience of or. where possibility becomes fact, not on paper, but in the only register that matters: awareness, the knowing that something happened. A small number of the people who built this theory followed that thought to its conclusion. They did not do so lightly. They were careful, precise, technically fluent, the least likely people in the world to mistake a mathematical frustration for a metaphysical truth. And they found, at the end of the chain, something that looked like mind. Not the mind of a human performing a calculation. Something prior to that. Something that the formalism seemed to require, and that no one knew how to put into an equation. Most of them turned back. Not because they were wrong to follow the chain, but because what they found at the end frightened them, and because science has no good language for what they found, and because the alternative had a name that physics did not want to say out loud. The name is idealism, the view that the ground of the world is not matter but mind, that what physics calls reality is, in some sense that remains technically unresolved, happening inside something closer to experience than to stuff. And here is the inversion that almost no one who repeats the title actually understands. The universe is in someone's mind. That much the argument may support. But whose? The answer on every serious version of this view is not the mind you think it is, not the personal self, not the dreamer of small dreams. Every rigorous form of idealism, every philosophical tradition that has pressed this view past the casual version and into the place where it becomes genuinely difficult, arrives at the same correction. If the universe is in a mind, then you're inside that mind. Not outside it, peering in. Inside. A figure in the dream, not the dreamer. The universe may be, in some formal sense, a feature of consciousness, but the consciousness in question is not the one that carries your name. The inversion is what the script holds, not the self made cosmic, the self made small. This question is much older than physics. Long before an electron was named, before a slit was cut in a barrier, before an equation was written, there were men and women who arrived by a completely different road, through years of sustained silence and rigorous discipline, through methods that have nothing in common with the laboratory, at something that wears the shape of this same inversion, that the world of separate solid things is a surface, that underneath the surface is something more like knowing than like stuff, that the self who seems to stand outside the world, examining it from a safe distance, is the deepest part of the illusion. These are not intuitions. They are findings held with the same seriousness that physics holds its own. The traditions will be named later, slowly, with precision. For now, only the shadow of them, a long shadow stretching back through centuries of human effort, converging in the dark on a shape that physics is only now learning to describe. The chair is still in the empty room. Something holds it there. The universe is going on tonight in 1,000 places where no one is watching. Or it is not. The question has never been answered, but it has been refined, sharpened in the last 100 years to a precision that could not have existed before, until it sits not in the library, but in the laboratory, where the answer, whatever it is, will eventually have to pass through the only tribunal that does not negotiate: the screen, the click of the detector, the world insisting on becoming one thing every time it is asked, without ever explaining why. And if the answer, when it finally comes, points toward mind, toward awareness as the ground rather than the product, then the question becomes not whether the universe is in a mind, but whose. That is the weight the rest of this carries. That is the architecture beginning to rise. Physics had been warning itself for years. The first sign came in 1924 in a doctoral thesis submitted to the University of Paris, written by a French aristocrat named Louis de Broglie, who had the strange idea that matter, not just light, but matter, actual particles with mass and momentum, has a wavelength. The committee did not know what to do with it. They sent the thesis to Einstein. Einstein replied that it was not only correct, but would open new windows on the structure of the world. It did. 3 years later, in 1927, two American physicists working at Bell Telephone Laboratories in New York, Clinton Davison and Lester Germer, confirmed it by accident. Firing electrons at a nickel crystal, they watched the electrons scatter into a pattern that made no sense if electrons were only particles. The pattern was a diffraction pattern, the signature of a wave. Something was interfering, something was spreading, crossing itself, canceling itself out, and reinforcing itself in stripes that matched the mathematics of de Broglie's wavelength precisely. The electrons were going where waves go. They were not going where particles go. The experiment left a question so clean, it has never gone away. If a single electron is a wave, what exactly is it a wave of? The answer to that question is the answer to nearly everything that follows. In 1926, Erwin Schrödinger, working at the University of Zurich, in a burst of work so concentrated that 4 major papers appeared in the same journal in the span of 6 months, wrote an equation for what the electron is waving. Not a wave of water, not a wave of pressure, a wave of probability amplitude. At every point in space, the equation assigns a complex number. Not a probability, but something more fundamental. An amplitude whose absolute square gives the probability. This last step, the squaring, the translation from amplitude to probability, was added the same year by Max Born, working in Göttingen, almost as a footnote in a paper on particle scattering. Born would wait 28 years for his Nobel Prize for that footnote. It is one of the most important footnotes in scientific history. The wave function, as it came to be called, does not tell you where the electron is. It tells you, for every possible location, how likely the electron is to be found there if asked. And between askings, it spreads, it flows, it diffracts and interferes. It behaves exactly as a wave should. And this is where the strangeness enters the mathematics precisely, not just philosophically. What Schrödinger's equation describes is a superposition, a state in which the electron is simultaneously in many places at once, each possibility carrying its amplitude, each amplitude contributing to the final pattern. When no one measures which slit the electron passed through, both amplitudes remain active. The amplitude for slit 1 and the amplitude for slit 2 coexist in the same wave function. At the far screen, these two amplitudes add together, and in places where one amplitude is positive and the other negative, they cancel. In places where both are positive, they reinforce. The result is the interference pattern, not a metaphor of a wave, the actual mathematical consequence of two amplitudes existing simultaneously and adding. In 1989, a team of physicists at Hitachi's Central Research Laboratory in Japan, led by Akira Tonomura, demonstrated this in the most precise and haunting way yet achieved. They sent electrons through a double-slit apparatus one at a time, separated by enough time that no two electrons could possibly interact. Each electron landed on a detector plate and registered as a single point. Alone, each landing appeared random. After 10 electrons, the screen showed 10 scattered dots. no pattern. After 100, still nothing that looked like order. But after 10,000, after 50,000, the stripes appeared. The interference pattern built itself from individual particles, each one apparently ignorant of where the last had landed, each one moving alone through a room in which no other electron existed. The pattern is not in any single electron. It is in the wave that describes all of them, or rather, in the wave that describes the possibilities open to each of them. The structure is there before any electron crosses. It waits. There is a human experience that is not quite the same, but wears the same shape. The experience of watching an order you did not design emerge from what appeared to be noise. The feeling when scattered things resolve, without announcement, into something that was always there underneath. Physics, in the 1920s, was having that experience at the most fundamental level it had ever reached. And the order it found was strange. Not the order of billiard balls on a table, but the order of waves, of interference, of multiple possibilities converging toward a pattern that required all of them at once. When a detector is placed at the slits, anything that records which path the electron takes, the interference vanishes. The stripes are replaced by two plain bands. The popular account says the electron is disturbed by being observed, that some sensitivity to human attention reaches down and collapses the pattern. This account has the right result and the wrong mechanism. The detector does not need to be read by anyone. It does not need to be conscious. What matters is that the detector and the electron interact, that they become entangled in the language of quantum mechanics, so that the state of the detector records the state of the electron's path. Once that entanglement exists, the two amplitudes, slit 1 and slit 2, no longer belong to the electron alone. They belong to the combined system of electron plus detector. And because the two detector states are physically distinct, because they record different information, the interference between the electrons' paths is no longer possible. The cross terms in the mathematics, the terms that produce the stripes, become zero, not because a mind willed it, but because the record exists. The information is the thing, not the looking, not the knowing, the physical fact of a record, anywhere, in anything. But saying this only makes the question more precise, not more answerable. The record in the detector is encoded in atoms. Atoms obey quantum mechanics. So why does the detector have a definite state? Recorded slit 1, recorded slit 2, rather than a superposition of both, entangled with the electron, spreading the indeterminacy further downstream. Something in the quiet of that question lives at the heart of the next century of physics. Schrödinger's equation is not modest in what it predicts. It is the most reliably confirmed equation in the history of science, and its predictions hold to 12 decimal places in some experiments, a precision unmatched by any other physical law. But the equation has a property that, once you see it, cannot be unseen. It is linear, perfectly, exactly, strictly linear. And linearity means this. If psi1 is a valid wave function and psi2 is a valid wave function, then any combination of the two, any superposition of them, is also a valid wave function. Solutions breed solutions. Superpositions under Schrödinger's equation evolve into more superpositions. Always. The equation never selects one possibility over another. It only ever spreads the possibilities, one entangled layer building on the last, smooth and deterministic and continuous forever. There is no collapse in Schrödinger's equation. The word collapse appears nowhere in the derivation. It is added afterward as a second rule, the measurement postulate, the Born rule, bolted onto the smooth mathematics like a different kind of law, one that does not follow from the first, that contradicts the first in its fundamental character. Schrödinger evolution is deterministic. The collapse is random. Schrödinger evolution is continuous. The collapse is instantaneous. The two postulates of standard quantum mechanics are not a unified theory. They are two incompatible descriptions of the world, stitched together at the seam of measurement, with no explanation of what happens at the seam. In 1935, Schrödinger himself, by then at the University of Berlin, reading a paper by Einstein, Podolsky, and Rosen that had appeared that spring, sat down and wrote a letter to Einstein that eventually became a published paper in the journal Naturwissenschaften. The paper introduced the word entanglement, Verschränkung, in German, the knotting together of two quantum systems so that their states cannot be described independently. And in the same paper, Schrödinger introduced a thought experiment that he meant as a demonstration of the theory's absurdity. A cat is placed in a box with a radioactive atom, a detector, and a vial of poison. If the atom decays, the detector fires, the vial breaks, the cat dies. If not, the cat lives. The atom is in a superposition of decayed and not decayed. The cat, by Schrödinger's equation, should be in a superposition of dead and alive. The experiment described a conclusion so repugnant that Schrödinger assumed it would force a revision of the theory. It did not. The cat became famous instead. What was meant as a protest became a mascot. This is the most important misreading in the public history of quantum mechanics, and it continues to mislead anyone who encounters the subject for the first time. Schrödinger was not celebrating the theory. He was appalled by it. The cat was designed to show that something was wrong. 90 years later, what is wrong remains named but not fixed. The strange persistence of the cat, the way a thought experiment designed to embarrass a theory, became instead the theory's most beloved image, says something about human beings and something about this particular field of knowledge. Schrödinger wrote his cat into a box and locked it there, expecting a resolution. The resolution never came. The cat stayed in the box, in superposition, for the rest of the century, and it stays there still, and no one has found the key. What he left was not a paradox that physics would solve. It was a mirror in which physics found itself unable to look away. What is wrong has a name. The measurement problem. It is this. Quantum mechanics, taken at face value, describes a universe that is always in superposition, a universe of and where every particle, every detector, every laboratory, every physicist's brain is in a smooth, deterministic superposition of all its possible states. The equation runs forward in time, linear and continuous, never choosing. Experience delivers something different. You open your eyes onto one world. The pattern is either there or it is not. The cat is either alive or it is not. The and becomes an or, and no one knows where, and no one knows how, and the equation says it should not happen at all. There are three distinct wounds in this problem, nested inside each other. The first is the preferred basis problem. Why does measurement produce a definite result in one particular basis? Position, momentum, spin, rather than in all possible bases simultaneously? The second is the problem of outcomes. Why, given that the superposition exists right up until measurement, does one particular outcome occur rather than all of them? The third is the problem of probabilities. Why do the probabilities follow the Bohr rule? Why does squaring the amplitude give the right prediction? Each of these has partial answers. contested answers, no answers. Together, they constitute the central unsolved problem in the foundations of the most accurate theory ever written. This is what physics actually says. Not that the measurement problem is a fringe concern for philosophers. Not that it was solved by decoherence in the 1970s. Not that it is a matter of interpretation only, with no physical content. The measurement problem is a physical problem. It is the problem of how the equation relates to the world. And it is open. The work of specifying this problem rigorously, of making the wound visible in full mathematical clarity, was done by a man who may have been the most gifted pure mathematician who ever turned his attention to physics. John von Neumann, the Hungarian mathematician who had already, by the age of 23, published foundational results in set theory, and who would go on to design the logical architecture of the modern computer, turned to quantum mechanics in the late 1920s and published, in 1932, a book called Mathematical Foundations of Quantum Mechanics. It is one of the most important scientific books of the 20th century, and one of the least read. In it, von Neumann did something that none of the founders of quantum mechanics had done precisely. He wrote the measurement process as a mathematical operation, expressed in the full language of Hilbert spaces and linear operators, and asked where the measurement actually happens. His answer was a chain. The quantum system being measured, the electron, interacts with the measuring apparatus. The apparatus interacts with a recording device. The recording device interacts with the sensory organs of the observer. The sensory organs transmit to the brain. The brain processes the signal. At every step, quantum mechanics applies. Every device is a quantum system. Every interaction is describable by Schrödinger's equation, and von Neumann proved, with the precision of a formal theorem, that the predictions of quantum mechanics are the same no matter where you place the cut. The boundary between the system described quantum mechanically and the system described classically. Put the cut at the electron, put it at the apparatus, put it at the retina, put it at the optic nerve, put it at the visual cortex. The numbers come out the same. The theory does not prefer one placement over another. The cut is real. Something must be described classically, because classical descriptions are how we record results. But the location of the cut is not fixed by the theory. It is arbitrary. It is placed by convention. This is the von Neumann chain. The chain extends through every physical system until it reaches the end. And the end is the one thing von Neumann named, but did not put into the equation. The abstract ego, he called it. The consciousness of the observer, the awareness in which the definite outcome finally registers. There is something almost disorienting in this result. The sensation of following a rigorous formal argument through one careful step after another, and arriving, with the full weight of the proof behind you, at something that does not feel like physics anymore. The chain runs through the apparatus, through the lab, through the body of the scientist, and it does not stop anywhere made of the same stuff as everything else. Von Neumann knew this. He put it in the book and moved on. One of the great mathematicians of the century, working in the cold language of Hilbert spaces, concluded that the measurement chain has no natural physical terminus. It reaches the end of matter and finds not an answer, but an opening. Two physicists took this opening seriously enough to name it. Fritz London, working in Paris, and his colleague Edmund Bauer published a short essay in 1939 during the period when the theory of quantum measurement was still considered an open philosophical problem rather than a settled technical matter. Their argument was direct. The measuring apparatus cannot terminate the chain because it is itself a quantum system, subject to superposition. The only thing that can terminate the chain, that can collapse the wave function and produce a single outcome, is consciousness, not the neurons, not the brain as a physical organ. Consciousness as such, the act of knowing. 2 decades later, a physicist of considerably greater standing took the same position in print. Eugene Wigner, who had won the Nobel Prize in 1963 for his work on the symmetry principles underlying particle physics, and who was one of the most respected theoretical physicists alive, published a short essay in 1961 titled Remarks on the Mind-Body Question. It appeared in a collection edited by a British journalist, not in a physics journal, which says something about the social cost of stating it. His argument followed London and Bohr. The von Neumann chain has no natural physical terminus. The wave function collapses when it reaches a conscious observer. Consciousness is physically real in a way that the standard quantum formalism cannot describe. Wigner was careful. He was not a mystic. He was not saying that mind creates matter in the self-help sense. He was saying, in the language of a working physicist, that the standard formalism has a gap, and that the gap is located at the interface between matter and awareness. He considered it a scientific problem, not a spiritual one. And then, slowly, over the following 2 decades, he turned back. The retreat was never dramatic. There was no single moment of recantation. But by the late 1970s, Wigner had moved away from the consciousness causes collapse position, and the reasons matter. The first reason was solipsism. If consciousness collapses the wave function, whose consciousness? If the answer is any consciousness, then why does one person's experience fix the world for everyone else? If the answer is all consciousness simultaneously, the problem becomes a many consciousness interpretation that generates its own difficulties. The view that looked like the natural terminus of the von Neumann chain turned out to open a second chain of problems at least as deep as the first. The second reason was decoherence. In 1970, a physicist in Heidelberg had published something that offered a physical explanation for the appearance of collapse, an explanation that required no consciousness at all. Wigner saw it. He adjusted. The most famous physicist to have endorsed consciousness causes collapse had effectively abandoned it before his death in 1995. This is almost never mentioned. The popular account of this subject treats Wigner's 1961 paper as the permanent position of a great physicist. The popular account is wrong, but the thought experiment Wigner left behind, the one he constructed in 1961 as a way of sharpening the problem, did not disappear with his change of view. It grew sharper. The thought experiment is simple to describe and difficult to resolve. Wigner is standing outside a sealed laboratory. Inside the laboratory, his colleague, call him the friend, performs a measurement on a particle that is in a superposition of 2 possible states, spin up and spin down. The friend performs the measurement and gets a definite result. From inside the laboratory, a fact has been established. The particle is spin up, or the particle is spin down. The friend knows which. From outside the laboratory, Wigner must describe the entire contents of the sealed room, the particle, the apparatus, the friend, using quantum mechanics, because that is what quantum mechanics requires. Quantum mechanics is universal, and quantum mechanics describes the contents of the sealed room as entangled. The combined state of particle plus friend is a superposition. The friend measured spin up and feels certain about that, combined with the friend measured spin down and feels certain about that. Both outcomes exist in Wigner's description. until Wigner opens the door and interacts with the system himself. From inside, a fact happened. From outside, it did not. Two irreconcilable accounts of the same moment, both derived from the same physical theory, applied by two legitimate observers. Whose account is correct? The answer, in the standard formalism, is unclear. The friend is a physical system, and physical systems obey quantum mechanics. Wigner is a physical system too. The moment Wigner opens the door and asks the friend what happened, the friend's answer, definite, unambiguous, consistent with the definite result they recorded, becomes the new input, and Wigner updates his description. Everything is internally consistent. Nothing is resolved. The problem is not that the accounts give different predictions. The problem is that they give different descriptions of what is real. One says something happened. One says it was not yet determined. One of them must be wrong, or the question must be ill-posed. The theory does not say which. Wigner knew this and left it open. What he did not know was that 60 years later, it would become a formal theorem and an experimental result. Those come later. For now, only the shape of the paradox, the friend who knew, and the physicist outside who could not yet say the friend knew, and the sealed room in which both descriptions lived without resolution. There is one other major position on the measurement problem, the one that most physicists, most of the time, actually hold in practice. And it must be named because it is almost always misrepresented. Niels Bohr, the Danish physicist who more than anyone shaped the culture of quantum mechanics in its founding decades, did not say that consciousness creates reality. This correction is important and almost universally overlooked in popular accounts. Bohr's position, the Copenhagen interpretation in its original form, was not idealist. It was not even close. Bohr said the question of what the electron is really doing between measurements is not a question physics should ask, because physics describes phenomena, not things in themselves. The wave function is not a real object out there in the world. It is a tool for predicting the outcomes of experiments. The classical/quantum cut is placed wherever it is convenient for the purpose at hand. Ask not what the particle is doing when no one measures it. Ask only what the instrument will record when it does. This is a form of anti-realism, not idealism. It is the difference between saying, the world is made of mind, and saying, physics cannot speak about the world as it is independent of measurement. The second position makes no claim about mind. It only claims limits on what physics can say. Werner Heisenberg, in Physics and Philosophy, published in 1958, put a slightly warmer gloss on it. The unmeasured particle exists as potentia, as tendency, not actuality, a strange kind of physical reality halfway between possibility and fact. That phrase is beautiful and precise and carefully non-committal. Heisenberg was not saying the particle is a thought in someone's mind. He was saying it is a possibility waiting to become a fact. The difference is not small. The Copenhagen position says, do not ask the question. The von Neumann chain says, the question demands an answer, and the answer is not in the formalism. Wigner said, the answer is consciousness. Then Wigner turned back. The question remained. The answer that the scientific community eventually converged on, the one that appears in modern textbooks as the resolution of the measurement problem, the one that most physicists cite when pressed, arrived in 1970 in a paper that its author had difficulty getting published. The journal Physics Letters rejected it. It eventually appeared in Foundations of Physics, a journal dedicated to the philosophical foundations of the field, which tells you something about how the mainstream viewed the problem. The author was H. Dieter Zeh, working at the University of Heidelberg, and the insight he published is called decoherence. The mechanism is this: a quantum system does not exist in isolation. It is always in an environment, surrounded by air molecules, photons, thermal fluctuations, electromagnetic fields, and these surrounding degrees of freedom are themselves quantum systems. The moment the quantum system of interest interacts with even one surrounding particle, the two become entangled. And the moment that entanglement exists, the interference terms, the mathematical cross terms that make superposition visible as interference, become practically unrecoverable. Not because they disappear, because to recover them, you would need to reverse the quantum state of every molecule in the room, and every molecule that those molecules have touched, and so on outward. The information about the superposition bleeds into the environment at an extraordinary rate. A single dust particle in a room decoheres in less than a nanosecond. A living cell in a fraction of that. The universe acts as a constant drain on quantum coherence, an incessant measurement by proxy, and what it leaves behind is a world in which everything large appears definite and classical, because the interference between its possible states has been diluted into the environment without hope of recovery. Wojciech Zurek, working at Los Alamos National Laboratory, extended this work through the 1980s and into the following decades, developing the theory of einselection, environment-induced superselection, and identifying the specific quantum states, which he called pointer states, that survive environmental decoherence and emerge as the stable, classical-looking facts of everyday experience. He went further still, developing an account he called quantum Darwinism, the idea that what we call objective reality consists of the information about a quantum system that has been redundantly copied into the environment, the states that survive because the environment has made many independent records of them. Reality, on this account, is not defined by what is observed. It is defined by what has been observed by so many independent parts of the environment that all observers, human and otherwise, agree on its properties. The chair in the room is real because the photons bouncing off it, the air molecules touching it, the electromagnetic fields threading through it, have all made a record. The record is redundant. The redundancy is the reality. The theory was elegant and persuasive and explained a very large set of observations that had previously required the awkward gesture of the collapse postulate. But here is what the theory actually explains, and what it does not. And the distinction is everything. Decoherence explains why we never observe superpositions in the macroscopic world. It explains why large objects behave classically. It explains which basis the measurement outcomes will appear in. It gives a physical derivation of the preferred basis, which was one of the 3 wounds named earlier. This is a real achievement. It is not a small one. Decoherence does not explain why one particular outcome happens, rather than all of them. In the full unitary evolution, in Schrödinger's equation, running without any collapse postulate, decoherence leaves all outcomes existing simultaneously, entangled with the environment, each in its own branch. The interference between branches is suppressed. The branches are separated, but they are all there. The problem of outcomes, why this one and not the others, is not touched by decoherence. The many worlds interpretation bites this bullet honestly. All outcomes happen in separate branches of the wave function. Most physicists are not comfortable saying this, but the alternative, claiming that decoherence resolves the measurement problem, requires ignoring the second wound in order to celebrate the partial closure of the first. The honest position is this: decoherence is the best physical answer physics has to the measurement problem. It narrows the wound considerably, and the wound is still open. There is a passage that deserves a moment of stillness before the next thing arrives. Physics spent roughly 50 years, from the late 1920s to the late 1970s, discovering the full dimensions of a single problem, that the most accurate theory in the history of science cannot explain the fact of a single definite outcome. It cannot explain why the cat is alive or dead, rather than some superposition of both. It can explain why you never see the superposition. It cannot explain why there is only one thing instead of all things. The work of those 50 years refined the problem until it was irreducibly precise. And at the end of that refinement, one option remained that most physicists refused to say out loud: that the cut cannot be placed within the physical chain at all, that something outside the chain must close it, that the something in question has a name, and the name is not physics. Most of the field continued, and continues, without trying to answer this. The predictions work. The machines work. There is work to be done that does not require resolving the foundations. There is a phrase associated with this posture, attributed to various people and probably originating with no one, that became the unofficial motto of post-war physics: shut up and calculate. It has served the technology well, but there were physicists who could not shut up. Physicists who looked at the chain extending from the electron through the detector, through the scientist, through the brain, and found the chain pointing somewhere they had not planned to go. One of them, later in his life, went further than any of the others. Not toward consciousness, but toward something stranger. Toward the idea that the question of where the cut belongs had been asked the wrong way from the beginning. That the cut was not a boundary between the observer and the world. That the observer was not in the world at all, looking in. That the world was inside the observation, looking out through it at itself. He was the man who had named the black hole, and he was not finished. John Archibald Wheeler had spent the first half of his career building the physics of the very large. Nuclear reactions, black holes, the geometry of space-time itself. He had given the black hole its name in 1967 at a conference in New York, coining the term the way a good physicist coins terms, from what the object does, not from what it is. The black hole is the place from which nothing escapes. The name stuck. Wheeler had not been thinking about observation. He had been thinking about gravity. And then something shifted. In the last decades of his life, Wheeler, working at Princeton and later the University of Texas, became obsessed with a different question. Not what the universe is made of, what the universe is made by. He had stared long enough at quantum mechanics to form a conviction that most of his colleagues thought too philosophical to take seriously. That observation was not a passive recording of pre-existing facts. It was a constitutive act. The observer was not reading the universe. The observer was, in some fundamental sense, writing it. He called it the participatory universe. He captured the idea in 3 words: it from bit. The it is everything: matter, space-time, the whole physical world. The bit is information, not information as a human construct, not information as a convenient description, information as the fundamental stuff. Wheeler's claim was that every physical quantity derives its being from an irreducibly participatory act, a yes or no question put to nature by an agent equipped to ask it. The universe is not made of particles. It is made of answers. And answers require questions. Questions require questioners. This was not mysticism. Wheeler was one of the most rigorous physicists of the 20th century. He was proposing a formal position about the ontological status of physical quantities. What he was saying, precisely stated, is this: no physical fact is fully real until it has been registered by a physical interaction capable of making a record of it. The measurement is not optional, it is constitutive. In 1978, he proposed an experiment to test the outer limit of this idea. The setup used the double slit, but with a modification so strange it has taken decades to fully absorb. A photon is sent toward the two slits. It passes through. On the far side, Wheeler proposed inserting a choice. The experimenter can decide, after the photon has already passed the slits, whether to set up the apparatus to measure which path information, or to let the interference pattern build. The choice is made after the photon is in flight, and the result, confirmed in laboratory experiments through the 1980s and in a definitive experiment by a French group in 2007, is that the photon's apparent past depends on the future choice. When the experimenter chooses to measure which path, the photon behaves as if it took one path. When the experimenter chooses to look at the interference, the photon behaves as if it took both. The choice is made after the photon has passed the point of no return. The photon's history is not fixed when the photon crosses the slit. It is fixed when the record is made. This is not retrocausality. The past is not literally rewritten. No signal travels backward in time. What the experiment shows is something subtler, and in some ways more unsettling. The photon's which path information does not exist as a fixed fact in the world until a measurement capable of registering it is made, regardless of when, and regardless of the photon's apparent position when the choice occurs. The information is not there waiting. It comes into being with the asking. Wheeler's vision. The universe is a self-excited circuit, a system that calls itself into being through the act of registering facts about itself. The observer is not outside the experiment. The observer is inside the loop. Wheeler pushed this thought to its cosmological limit. He proposed a version of the delayed choice experiment in which the slits are two paths around a gravitational lens, a massive galaxy bending the light of a quasar behind it, billions of light years away. The photon left the quasar billions of years before the Earth existed. It has been in flight for longer than human civilization, longer than the solar system. On the far side of the lens, a telescope on Earth can choose tonight whether to measure which path the light took around the galaxy, or whether to let the two paths interfere. The photon's history, billions of years old, remains undetermined until a detector on this planet makes a choice. The past is not the past in the simple sense. It becomes the past at the moment it is registered. A universe with no one in it to register anything has, on this view, no settled past at all. There is something in that image worth sitting with for a moment before going further. You have had the experience of a memory that changes slightly depending on how you ask about it. The past that seems to shift at the edge of attention. Not fabricated, not false, just not entirely fixed until the asking. The photon's situation is formally analogous and formally documented and formally unresolved. The universe remembers what it has been asked. It does not know in advance everything about what it has been. Physics, following this thread, arrived at an experiment so routinely misunderstood that it is worth spending time on what it actually shows. In 2000, a team including Yoon-Ho Kim and Marlon Scully had spent a career at Texas, A&M, and later Princeton, building one of the sharpest technical minds in quantum optics, published a paper that produced, in certain online circles, the conviction that physics had proven human beings can change the past with their minds. The experiment is called the delayed choice quantum eraser. The results are real. The interpretation commonly attached to them is not. Here's what the experiment actually does. A pair of entangled photons is generated. One photon, the signal, goes through a double-slit apparatus and lands on a detector. Its entangled partner, the idler, goes to a different detector, where its witch path information is either preserved or erased through a subsequent optical interaction. The question is, does the signal photon show an interference pattern or not? The popular version of the result says this: when you erase the witch path information of the idler, the signal photon retroactively shows interference, as though it went back in time and chose to go through both slits after you decided to erase the record. Your decision about the future changed the past. This is what thousands of videos on the internet say the experiment shows. It is not what the experiment shows. Here is what actually happens. The signal photon's detector records are fixed before anything is done to the idler. The signal photons, in aggregate, never show an interference pattern in the raw data. What the analysis reveals, afterward in post-selection, is that when you sort the signal photons by correlating them with specific idler outcomes, two subsets emerge that each show an interference pattern. The interference is there, hidden in the correlations, before any erasing is done. The erasure does not cause the interference. It reveals a pre-existing correlation. No signal travels backward. No decision about the future changes a record in the past. The raw detector data is fixed. Always. What is genuinely strange is this: the interference pattern never appears in the unfiltered data. It only appears in the subsets defined by the correlation. Whether the past looks like a wave or a particle depends on which subset of the correlations you choose to examine, and that choice can be made after the signal photon has already landed. The witch path story and the interference story are both present in the data, and which one emerges depends on how you look at it, not on what happened to the photon, on what you choose to ask about the idler. The past is not changed, but which aspect of the past is visible depends on a question asked about the future. That is the genuine strangeness. It is enough. A theorem published in 2018 pushed further than any experiment had reached. Daniela Frauchiger and Renato Renner, working at ETH Zurich, proved something that Wigner's thought experiment had only suggested. They showed formally that quantum mechanics applied consistently to observers who themselves use quantum mechanics generates irreconcilable facts, not just different perspectives on the same event, logically incompatible conclusions about the same physical outcome derived by different observers from the same physical process. The paper's title was not modest. Quantum theory cannot consistently describe the use of itself. The setup extended Wigner's friend to 4 agents, 2 inner observers, friends inside sealed laboratories, make measurements on quantum systems and record definite results. 2 outer observers, Wigners, standing outside the sealed labs, apply quantum mechanics to the entire contents of each sealed system, including the friends and their measurements. Under certain conditions, the outer observers derive predictions about the inner observers' conclusions. And when those predictions are compared, they contradict each other. 2 rational agents, each following the rules of quantum mechanics correctly, arrive at mutually exclusive claims about the same fact. This is not a matter of perspective. 2 people looking at the same sculpture from different angles still agree on how many arms it has. The Frauchiger-Renner scenario produces observers who, by rigorous calculation, deduce incompatible facts about a single physical event, and the incompatibility cannot be resolved by communicating or comparing notes. It is built into the structure. The theorem proves the inconsistency by resting on three assumptions. First, quantum mechanics is universally valid. It applies to observers as well as electrons. Second, agents can reason consistently from their own measurements. Third, the facts recorded by one agent can be combined with the facts recorded by another. At least one of these assumptions must be false. The different interpretations of quantum mechanics can be partially distinguished by which assumption they abandon. Many worlds gives up the uniqueness of facts. In each branch, agents simply do not share a world. Copenhagen effectively limits universality, refusing to apply quantum mechanics to the measuring apparatus. Cubism gives up the third assumption most directly. An agent's fact is strictly their own, not transferable to others without becoming something different. The theorem is not a refutation of quantum mechanics. It is a diagnostic tool for what any viable interpretation must sacrifice. This is genuine progress. It is not a resolution. There is a human experience that maps the shape of this, loosely and imperfectly. Two people witness the same moment. Each remembers it definitively. Each memory is internally consistent. The memories do not agree, not in the way of faulty recall, but in the way of genuinely different facts, each arising from a different perspective that cannot be fully translated into the other. The Frauchiger-Renner theorem is the formal version of this, not as psychology, as physics. Two observers, same event, incompatible facts, both derived correctly. Quantum mechanics, applied to itself, produces this. 3 years after the theorem, an experiment pushed the question into the laboratory. In 2019, Massimiliano Proietti and colleagues at Heriot-Watt University in Edinburgh built a 6-photon system designed to realize an extended version of the Wigner's friend scenario. 6 entangled photons, playing the roles of 2 friends and their outer observers. The measurements were made, the data was collected. The result was consistent with the conclusion that 2 observers in the experiment recorded genuinely incompatible facts about a single quantum event, not just different descriptions, genuinely incompatible. If observer-independent facts about quantum events exist, the data says, the kind of independence they would require is ruled out by the correlations. The honest caveats must be stated. The friends in this experiment are photons, not conscious beings. The measurements are performed by optical devices, not by cognitive agents with inner lives. Whether this experiment says anything about human observers is contested. What it does say, cleanly, reproducibly, with full statistical confidence, is that a certain formal property, the existence of single observer-independent facts compatible with quantum mechanics, fails. The common-sense bedrock of scientific realism, every event has exactly one fact attached to it, accessible in principle to any observer, is not compatible with the quantum mechanical description of this specific class of experiment. The direction of travel is not subtle. The idea of a single, objective, observer-independent fact for every physical event is under genuine strain from within the formalism. Strained is not the same as broken, but the strain is documented and reproducible. Settle here for a moment. The listener who has been tracking these results from the beginning may feel a kind of accumulated pressure, not urgency, not alarm, but the weight of something slowly becoming clear. Each experiment holds. Each result is confirmed. The data is not ambiguous. And yet what the data adds up to is not a conclusion. It is the precise, well-measured shape of an open question. The universe does not collapse its own mystery simply because the instruments are good enough to map its dimensions. The mystery deepens as the measurement sharpens. This is not a failure of science. It is science doing exactly what it does best, arriving at the edge of what the method can answer, with the problem stated more cleanly than it has ever been stated before. And so, a question that had been philosophical began, slowly, to look more like an empirical one. If facts are not fully observer-independent, if the witch path story and the interference story each require a different observer to become visible, then perhaps the question of what the wave function is and what it represents is also less settled than textbooks suggest. A group of physicists from the early 2000s onward took that question seriously enough to propose a radical answer. Christopher Fuchs, Carlton Caves, and Rudiger Schack. Fuchs had been at Bell Labs before moving to a series of academic positions, and was one of the most creative quantum information theorists of his generation, developed a position they eventually called cubism, short for quantum Bayesianism. The name points at the core claim. Bayesianism is the view that probabilities are subjective. They represent an agent's degrees of belief, updated by experience, not objective frequencies in the world. Cubism applies this to quantum mechanics. The wave function is not a real physical object. It is an agent's personal probability assignment over possible measurement outcomes, not a property of the electron, a property of the agent in relation to the electron. When an agent makes a measurement, on this view, they are not revealing a pre-existing fact. They are having an experience, a genuine, irreducible event in their life that gives them new information to update their expectations. The measurement is an action. The outcome is a fact, but it is a fact for the agent, not a fact in the universe independent of any agent. What cubism is not, it is not idealism. The world is real. Electrons exist. Rocks exist. The moon exists when no one is looking at it, because it is constantly measured by its environment in the decoherence sense. Cubism does not say the world is made of mind. It says the wave function is not the world. The wave function is a tool for thinking about the world as an agent embedded within it. What cubism is not, it is not solipsism. Other agents are real. Their experiences are real. Their facts are not your constructs. Cubists insist on this. Their position is closer to American pragmatism, the philosophy of William James and John Dewey, than to any form of idealism. Science is a guide to action. The wave function is the best guide physics has found. It says nothing about what lies underneath the action, but there is a shape in cubism that matters for where this inquiry is going. In cubism, measurement is not the passive recording of a pre-existing state. It is a contact, an engagement, a genuine encounter between an agent and the world that produces a new fact on neither side alone. The boundary between knower and known is not a fixed wall. It is a site of creation. That shape has appeared before in human thought, in a completely different register, with completely different methods. This script will not rush to say where, but the shape is there and it is worth noticing. Let it settle. Let the density thin for a moment, the way a breath releases. There is something about the accumulation of these results that invites a particular kind of vertigo, not the vertigo of confusion, but the vertigo of a ground that turns out to have less floor than expected. Delayed choice. The photon's history is fixed by a future question. Frauchiger-Renner. Two observers applying quantum mechanics correctly to each other arrive at incompatible facts. Proiety. Observer-independent facts fail a laboratory test. QBism. The wave function belongs to the agent, not the world. Each of these individually admits a conventional explanation. Together, they suggest something that is not yet a conclusion, only a direction. Not all physicists feel the vertigo. Most do not. But for those who do, the feeling is precise. It is the feeling of a seam becoming visible. Two thinkers have followed the seam past where physics stops. Donald Hoffman, a cognitive scientist at the University of California, Irvine, has developed an argument he grounds in evolutionary game theory. In a series of papers with Chetan Prakash and Manish Singh, he proved a formal result sometimes called the fitness beats truth theorem. Run evolutionary simulations. Organisms that perceive the world accurately, that see reality as it is, are systematically outcompeted by organisms that perceive only what is relevant for survival, even when the survival relevant perception is systematically false. Evolution selects for fitness, not for truth. The conclusion Hoffman draws: natural selection cannot be expected to have given us accurate perceptions of the underlying structure of reality. What we call space-time, the three-dimensional world of objects in space and time, is an interface, like the desktop icons on a computer screen. The icons are not the hard drive. They are the interface between the user and a system too complex to interact with directly. Space-time is not the fundamental reality. It is our species-specific interface with something we do not and cannot see directly. Mark this carefully. This is not physics. This is cognitive science and philosophy, informed by physics, pointing past physics. The fitness beats truth theorem is a formal result in its own domain. Whether its domain connects to the measurement problem in quantum mechanics is not established. Hoffman has proposed a framework of conscious agents as the underlying reality, a mathematical formulation in which elementary units of experience interact and compose into larger complexes. The framework is coherent. It is currently unfalsifiable. It is not endorsed by the physics community. These are facts, and the script does not hide them. Bernardo Kastrup, a Dutch philosopher who spent years in scientific computing before turning to philosophy full-time, has developed a related position he calls analytic idealism. The central claim: there is one field of experience, he calls it mind at large, and what we call the physical world is what that field looks like from the outside. Individual human minds are, on this view, dissociated regions of the larger field. The way a single mind in dissociative identity disorder can host multiple apparently separate personalities who do not know about each other, each with their own memories and sense of self, each real, none of them separate beings. The physical world is what the mind at large's inner life looks like from the perspective of one of its alters. The position is serious philosophy. It is not crack pottery. It is also not physics. It is not falsifiable in its current form. It cannot be confirmed or disconfirmed by any experiment now conceivable. Kastrup's argument is that it is more parsimonious than materialism, that a single field of experience posited at the foundation requires fewer unexplained brute facts than consciousness emerging from inert matter. This is a philosophical argument about explanatory parsimony. Whether parsimony tracks truth is itself a philosophical question without a settled answer. Both positions are named here because they exist, they are serious, and they are part of the landscape that this inquiry generates. Neither is a conclusion. Both are live possibilities at the edge of what is known. And here is the honest position. Not the popular version, the precise one. It is often said, in books, in videos, in the kind of sentence that gets shared 1,000 times without anyone checking, that quantum mechanics proves consciousness creates reality, that modern physics has confirmed what the mystics always knew, that the observer is the author of the world. This is not what quantum mechanics says. It is not close to what quantum mechanics says. The measurement problem is open. That means multiple interpretations are viable. Idealism is among the viable interpretations. Being viable is not the same as being proven. The difference is everything. Most working physicists are not idealists. The mainstream position is decoherence plus shut up and calculate. It works. It produces accurate predictions. It does not settle the question of interpretation, but it refuses to be distracted by it. Consciousness causes collapse was proposed, elaborated, and then abandoned by its most prominent advocate, who was not a mystic, but a Nobel laureate in physics. Wheeler's participatory universe is suggestive and unproven. Cubism is a serious technical position that its own architects would resist having used as a bridge to spiritual conclusions. Frauchiger-Renner is a theorem about formal consistency, not a statement about what reality is made of. The Proietti experiment tests a formal property of observer independence in a laboratory setting using photons. What is established? Quantum mechanics is accurate. Decoherence is real. Observer-independent facts of a certain formal kind fail a laboratory test. These are facts. They are not contested. What is not established? That consciousness is the ground of reality, that your mind creates the world, that the universe is waiting for you to observe it into being. These are not physics results. They are philosophical positions of varying degrees of rigor, none of them confirmed by any experiment, none of them close to consensus. The measurement problem is open because it is hard, not because it has been secretly solved by the traditions, not because physics is on the verge of endorsing any particular metaphysical position. It is open the way a wound is open. Something real and important has not yet been explained. The explanation will, when it comes, be stranger than the popular version of the mystery. It will not be comfortable. It will require giving something up. Physics has now done everything physics can do with this question. The experiments are in. The theorems are proved. The interpretations are mapped. The question remains standing at the foundation, exactly as it was stated, and the method that generated the question cannot by itself answer it. Not because physics is wrong, because the question has arrived by physics's own machinery at a place where measurement ends and something else must begin. That something else has been working in a different room for a very long time. It has not been idle. It has not been waiting for physics to arrive and validate it. It has been asking, by its own methods, a question that now wears an almost identical shape. The roads are different. The conclusions are not the same, but something about the silence at the end of both roads sounds, from here, like the same silence. 3 centuries before the first quantum was measured, a bishop in Ireland solved a problem that physics would later spend 100 years creating for itself. George Berkeley, Bishop of Cloyne, publishing in 1710 a treatise that his contemporaries largely dismissed, proposed that material substance, as philosophers understood it, does not exist. Not that it is unknown, not that it is hard to perceive, that the category matter existing independently of perception is incoherent from the start. The essa of things, their being, is their percipi, their being perceived. A thing that exists without being perceived anywhere, by anyone, is not a thing at all. It is a philosophical ghost. The popular version of this idea says it is a recipe for solipsism. that Berkeley was claiming the world exists only in your mind and collapses when you stop looking. This is exactly wrong. Berkeley was the most famous anti-solipsist in the history of philosophy. He introduced God specifically to prevent solipsism. The chair in the empty room does not cease to exist when you leave, because God never stops perceiving it. Reality is stable not despite being perception dependent, but precisely because it is held in an attention that never sleeps, never turns away, never closes its eyes. The universe is in a mind. That mind is not yours. You are in it. This is not the conclusion of physics, but it is the shape of a question that physics has now arrived at from a completely different direction. And this question, who perceives when you are not perceiving, what holds the world in being between one observation and the next, has been asked by human inquiry for far longer than Berkeley's 3 centuries. The roads that follow are older. They are not faster. They do not arrive at Berkeley's answer. But what they find, working from the inside, from the structure of experience itself, wears a shape that deserves precise attention. The first road came from the southern tip of India in the 8th century, from a philosopher named Shankara, whose full name is Adi Shankaracharya, the first teacher, the one who would systematize the school of thought known as Advaita Vedanta, which means the non-dual end of the Veda. Non-dual, not two. Not the unity of many things, but the denial that there were ever two to unify. Shankara wrote voluminously, commentaries on the major Upanishads, on the Bhagavad Gita, on the Brahma Sutras. But his deepest teaching is compressed into a few sentences that still carry the weight of the investigation behind them. The world of separate things is Maya, appearance, not illusion in the sense of hallucination, not a mistake you made, but appearance in the precise sense. A mode of presentation that does not correspond to the underlying structure. Brahman, the ground of being, pure awareness without content, is the sole reality. The distinction between the ground of the universe and the ground of individual awareness is itself part of the appearance. This is what the 6th chapter of the Chandogya Upanishad says, in a teaching attributed to the sage Uddalaka Aruni, instructing his son Shvetaketu. 9 times, in different images, salt dissolved in water, rivers running into the sea, the sap in a tree, Uddalaka returns to the same conclusion. The finest essence of everything that exists is the same as the innermost reality of you. He says it in Sanskrit as you are, that tattavam asi, and the saying has been misquoted ever since. The popular reading hears it as, you are divine, as a compliment, an elevation of the self. Uddalaka meant the reverse. The That is Brahman, the groundless ground, prior to all name and form, without qualities, without parts. And the you he is addressing is not the personality, not the mind, not the body. It is the awareness in which all those arise. The sentence is not a compliment. It is a dissolution. What you thought you were is subsumed by what you actually are. But the hidden teaching that even most students of Advaita miss, the one that was transmitted quietly, rarely printed in introductory books, was articulated by Gaudapada, the teacher of Shankara's teacher, in a text called the Mandukya Karika, a commentary on the 12 verses of the Mandukya Upanishad. Gaudapada's position is called non-origination, ajativada. The claim is not the world is mental. It is more radical. Nothing was ever actually created. There is no origination, no arising. Not even the appearance of the world arose in any real sense. There is only the undivided ground, and the apparent multitude of experiences is like a circle of fire traced by a world torch. The circle is not there, has never been there, but is mistaken for something real by the eye in motion. Even Shankara's Maya is too much for Gaudapada. Maya at least gives the world some provisional reality as appearance. Ajatavada removes that. The appearance of arising is itself the last residue of the confusion. The popular version of Advaita says all is one. It is the most comfortable possible reading. What the tradition actually transmits is more demanding. Not that many things are secretly one, but that the many was never real to begin with. Not that unity exists under the apparent multiplicity. That multiplicity was never there. The languages are entirely different from what the physics of Movement 3 developed. The methods, the rigorous phenomenological analysis of the waking, dreaming, and deep sleep states that forms the backbone of Advaita's investigation, have nothing in common with laboratory measurement. But the architecture is the same. Gaudapada's Ajativada and the universal wave function that never actually collapses, that simply continues, smooth and deterministic, with all apparent outcomes existing simultaneously in the full unitary evolution, are not the same claim. They are not close to the same claim. The method of one is logical analysis of experience. The method of the other is mathematical physics. But the structural conclusion is identical in its shape. At the level of the whole, nothing ever happens. The appearing of events, of arising and ceasing, is a feature of the local viewing, not of the global ground. Shankara's image for this, the snake and the rope. In poor light, a rope on the path is mistaken for a snake. The terror is real. The reaction is real. But the snake was never there, only the rope. The rope was always the rope. And when the light comes, when the understanding arises, it is not that the snake becomes the rope. The snake simply ceases because it never was. The world of separate arising things is the snake. The undivided ground is the rope. And what changes is only the quality of the light. The school that Shankara's Advaita most rigorously argued against, and in arguing against incorporated, had reached the same depth from a different direction 4 centuries earlier. Asanga, in the 4th century of the Common Era, working in what is now northern Pakistan, founded with his half-brother Vasubandhu, the school known in Sanskrit as Yogacara, the practice of yoga, the discipline of attending precisely to the structure of experience itself. Vasubandhu compressed the entire framework into 2 short texts, the Vimsatika, 20 verses, and the Trimsika, 30, each followed by his own auto-commentary. They are among the most precisely crafted philosophical texts in the Buddhist canon. What Yogacara proposes is a structure of mind deeper than ordinary psychology. There are not the usual 5 or 6 senses. There are 8 layers of what the tradition calls consciousness. The ordinary 6, sight, hearing, smell, taste, touch, and the mental faculty that integrates them, are the surface. Below them lies a 7th, the manas consciousness, the layer that generates the persistent sense of a self, the one that stands behind each experience and claims it, that says, I saw, I heard, I am the one to whom these things happen. And below that, the 8th, the substrate consciousness, alaya vijnana, the ground layer beneath the sense of self, the current that carries the patterns forward, the field in which all experience is rooted. The alaya vijnana is commonly described in popular accounts of Buddhism as a storehouse consciousness that preserves memories between lives. This is accurate as far as it goes. It goes nowhere near far enough. What the tradition actually transmits about the alaya vijnana, in the texts and in the lineage commentaries that do not circulate widely, is that it is not personal. The individual psyche does not own the alaya vijnana. It arises from it. The alaya is described in the Mahayana Samgraha, Asanga's major systematic work, as like a river, always moving, never the same moment to moment, but maintaining continuity. Also as like an ocean, the surface waves of ordinary experience arise on it, but the ocean itself is not disturbed. The individual stream of experience is a pattern running through the field. It is not the field. It is often said that Yogacarra's mind-only school teaches that everything is a projection of your private mind, that external reality is a construct of individual consciousness. This is the popular reading. It is almost entirely wrong. The careful reading, developed over decades by scholars including Dan Lusthaus, whose Buddhist phenomenology traces the actual argument of the texts with precision, holds that Yogacarra is not subjective idealism in the Western sense. It is a phenomenological analysis of the knowing relation. The claim is not that the external world does not exist, but that you have no unmediated access to it. Everything that appears in experience appears as experience. The inference to a world behind the experience is exactly what Yogacarra asks you to examine. Not to deny the world, to suspend the unexamined certainty about what the world is. The structural parallel to the physics is precise but asymmetric. Cubism says the wave function is an agent's personal probability assignment, not a thing in the world. Yogacarra says experience is structured by the knowing relation, not a transparent window onto things in themselves. The architecture is the same. What we call the world as it is turns out to be, on close examination, always the world as experienced from within a particular mode of knowing. The ground that is prior to that, the alaya beneath individual experience, the world prior to the wave function, is there, but it does not come with the form we impose on it. The languages are different. The methods, meticulous attention to the structure of conscious experience versus the mathematics of probability and Hilbert space, are not comparable. The architecture is the same, and neither tradition says that the universe is in your mind. Both say the universe appears through a mode of knowing that has a structure, and the structure runs deeper than your individual perspective, down to a ground that neither tradition pretends to have fully mapped. Vasubandhu's image for this, the dreamer. In a dream, mountains and rivers and other people and events seem entirely external. They seem to be out there, independent, with their own existence apart from you. And yet, they arise within the dream without any external world corresponding to them. Vasubandhu does not conclude from this that waking life is a dream. He asks a more careful question. What is the evidence that waking experience differs in this respect from dream experience? The feeling of externality, of the world being out there independent of the knowing. That feeling is present in both. The question is whether the feeling is evidence. The question is still open. Let this settle for a moment before the next road begins. 3 centuries separate the Indian Buddhist philosophy just described from the Sufi tradition about to be named. Different continents, different languages, different conceptual frameworks, different practices. The methods of inquiry are not comparable. A Buddhist monk attending to the structure of consciousness in seated meditation has nothing in common, technically or institutionally, with a Sufi master moving between Mecca and Konya and Damascus in a life of visionary scholarship. The convergence is not the result of borrowing. It is not the result of a common perennial philosophy diffusing through the world's cultures. It is the result of 2 different rigorous investigations arriving, independently, at the same structural shape. The shape is more interesting than either tradition because no single tradition owns it. Muhyiddin ibn Arabi, born in Murcia in 1165 and eventually buried in Damascus in 1240, is known within the Sufi tradition as al-Sheikh al-Akbar, the greatest master. He wrote continuously throughout his life. The Meccan Revelations, his major work, fills 37 volumes in manuscript. The Bezels of Wisdom, written near the end of his life, is denser. 27 chapters, each a facet of a jewel, each a prophet as the vehicle of a divine name. These texts were considered dangerous enough that the Orthodox tradition spent several centuries working to have them banned, burned, reinterpreted, or diluted. The dangerous teaching is called the unity of being, Wahdat al-Wujud. The claim, there is only one being. Not that everything is part of a larger being, not that all things share a divine spark, but that there is a single actuality of existence, and everything that appears to be a separate existent is a mode of self-disclosure of that one being. Ibn Arabi grounds this in a tradition that circulates within Sufi lineages, though its canonical status is debated. I was a hidden treasure, and I loved to be known, so I created the creation. God, or the real, as Ibn Arabi calls the ultimate, was self-sufficient and undifferentiated, and the cosmos exists because the real needed a mirror, not metaphorically, ontologically. Without something other than itself, the real's names and qualities have no locus of manifestation. The world exists as the face in the mirror. The real is the one looking. But what most accounts of Ibn Arabi stop at, Wahdat al-Wujud, is only the first level of what the tradition actually transmits. The hidden teaching, almost never encountered in popular Western presentations, is the doctrine of the imaginal realm, Hadrat al-Khayal. Ibn Arabi's ontology has 3 levels: pure spirit, gross matter, and between them a third kind of reality that is neither. The imaginal realm, Hadrat al-Khayal, is not the psychological imagination, not fantasy or projection. It is an ontological category, a domain of forms that have genuine existence, that can be perceived, that have causal effects, that are neither purely mental nor purely material. It is the barzakh, the isthmus, the threshold between spirit and matter, the realm of the prophetic visions, the angels, the forms of the divine names as they appear in creation. The cosmos, on Ibn Arabi's account, is itself the imaginal level. It is the form in which the real imagines itself, not a physical world that minds subsequently perceive, a cosmic imagination that is itself the substance of what we call the physical world. The Orthodox tradition found this irreconcilable with the distinction between creator and creation. The tradition's defenders tried, for centuries, to argue that Wahdat al-Wujud did not mean what it appeared to mean. The hidden teacher does not make that argument. It means what it says. The popular version of Ibn Arabi in the West reduces his teaching to everything is God/divine love is everywhere / the universe is made of light. This is the warm version. The cold version is more precise. The cosmos exists as the necessary structure of a self-knowing. It could not exist because the real without a locus of self-disclosure would be an undifferentiated potential that never knew itself. Creation is not optional. It is the structure of a knowing that had no choice but to manifest. The languages differ by every measure from Wheeler's participatory universe. The methods, Sufi speculative theosophy informed by prophetic vision versus quantum measurement theory, do not overlap, but the architecture is the same. Wheeler, the universe is a self-excited circuit. bringing itself into being through acts of observation, existing because it is registered. Ibn Arabi. The real is a hidden treasure that loved to be known and created creation as the mirror of its self-knowing. In both, the universe exists, not despite the need for an observer, but because of it. In neither is the observer separate from what is observed. The observer is the world's way of knowing itself. This is not validation. Physics did not confirm the tradition. The tradition did not predict the physics. The convergence is architectural. Two investigations, using completely different methods and vocabularies, arrived at the same structural shape. In the same century that Ibn Arabi was writing in Damascus, in a language and tradition with nothing in common with Sufi thought, a Dominican friar in the Rhine Valley was preaching sermons that would eventually draw the attention of the papal inquisitors. Meister Eckhart, born around 1260, master of theology at Paris, preacher and spiritual director at Erfurt and Strasbourg, was not trying to be radical. He was trying to be precise. The sermon that became the most quoted and most condemned passage in his corpus was delivered, most likely, to a congregation of nuns who had no formal training in scholastic philosophy. He said, "The eye through which I see God is the same eye through which God sees me. My eye and God's eye are one eye, one seeing, one knowing, one love." The condemnation came after his death. Pope John XXII issued the bull in Agro Dominico in 1329, targeting 28 propositions from Eckhart's work as heretical or dangerously close to it. The condemnation targeted, more than anything, exactly this claim, that the boundary between the created soul and the uncreated God is not final. To understand what Eckhart was saying, the technical machinery must be named. Medieval Christian theology, following Augustine and Aquinas, held that all creatures pre-exist as ideas in the divine mind, the eternal reasons, the rationes aeternae, in a more perfect mode than they exist in the world. The world is, in a precise technical sense, God's thought given outward being. Aquinas went further. God is not a being among beings, but ipsum esse subsistens, being itself subsisting, the pure act of existing in which all things participate. The world does not exist beside God. It exists by participating in God's act of being. Eckhart took this framework and pushed past it into a distinction that almost no previous thinker had made with the same precision. He distinguished between God, the personal God, the Creator, the Trinity, the one who acts and creates and loves, and the Godhead, Gottheit, what underlies even the personal God, the ground prior to all distinction, prior to the three persons, prior to any act. The Godhead is, in Eckhart's language, pure nothingness. Not nothingness as absence, but nothingness as the plenitude before all determination. It is the silence before any word, the stillness before any movement. And then the claim that drew the condemnation. The soul has a ground, the ground of the soul, Seelengrund. And at that deepest level, the ground of the soul and the ground of God are one ground. Not similar, not in communion, not even in mystical union. One. The uncreated spark within the soul, what Eckhart calls das Fünklein, is not created. It was never created. It exists outside time, outside the order of creation, in the Godhead itself. What the condemnation tried to prevent was not mysticism. It was the claim that the seam between creator and creature, between the knowing and the known, does not go all the way down. The inquisitors were right to find it dangerous. The claim is that the universe is not, at its deepest level, in someone else's mind. It is in a ground that is neither yours nor anyone else's, because at that level, the distinction between yours and anyone's has already dissolved. The structural parallel to the physics is the most precise of all the parallels in this movement. The von Neumann chain reaches a terminus where the cut between observer and observed becomes unplaceable. Eckhart's chain of knowing, traced down from ordinary cognition through the intellect through the soul's ground, reaches a terminus where the distinction between knower and known dissolves. In both cases, the method of following the chain to its end produces not a final subject looking at a final object, but the disappearance of the distinction. The languages are incomparable. The method of scholastic philosophy and mystical theology is not the method of linear algebra on Hilbert spaces, but the architecture is the same. 1,000 years before Eckhart, in the Warring States period of ancient China, a philosopher named Zhuang Zhou, known to history as Zhuangzi, asked the question from the inside of a story so small it seems to dissolve before you have fully held it. He dreamed he was a butterfly flying freely, with no awareness of being Zhuang Zhou. Then he woke, and he found himself sitting as Zhuang Zhou. He could not say, could not decide, but philosophically could not say whether he was Zhuang Zhou, who had dreamed of being a butterfly, or a butterfly now dreaming of being Zhuang Zhou. The two possibilities were not resolved by the waking. The waking is just another state. The ground on which you stand to declare one state more real than the other is not more stable than either state. This is from the chapter called The Discussion on Making All Things Equal, the Qiwulun, which is not about evening out differences or achieving harmony. It is about the leveling of all distinctions at the point where they arise. The recognition that the categories by which we assign greater and lesser reality to different states of experience are themselves part of the experience we are trying to evaluate. The question cannot be answered from inside the question. The Tao Te Ching, the foundational text of Taoism attributed to Laozi and probably composed in the 4th or 3rd century BCE, is the text that most Western readers encounter first. But what almost no popular account of Taoism includes is the fact that the text has two radically different interpretive traditions, producing two radically different Taos. Wang Bi, a philosopher of the 3rd century CE, read the Tao through the lens of non-being, Wu, the principle that what makes the Tao, the ground of all things, is precisely that it is itself without determination, without quality, without form. The Tao is what makes possible the arising of the 10,000 things precisely because it is not any of them. Chapter 40 of the text states it plainly. The 10,000 things arise from being. Being arises from non-being. The ground is an absence that generates. But the Heishang Gong commentary, older, physiological, almost entirely absent from Western Taoism, reads the Tao not as a metaphysical abstraction, but as the vital substrate of the living body and the living cosmos, accessed through practices of breath and stillness and return. For Heishang Gong, the Tao is not nothing. It is the generative fullness that underlies and sustains the physical world, and the path to it runs through the body, through the deep quiet of organized attention, not through philosophical argument. The popular Western reception of Taoism received Wang Bi's version almost exclusively. The practicing lineages, the ones that transmitted the operative content, the methods, the cultivation, carried Heishang Gong's reading in their practices long after his commentary was forgotten by scholars. The structural parallel to the quantum vacuum, the Tao as the ground from which the 10,000 things arise and into which they return, parallels the quantum vacuum as the lowest energy state from which virtual processes arise and into which they return. Chapter 11 of the Tao Te Ching, the chapter about the wheel's hub, the clay vessel's hollow, the room's open space, says, "It is the emptiness that makes them useful." The functional capacity of a wheel depends on the absence at its center. The capacity of a room depends on the space that is not walls. The Tao, as ground, is useful precisely as what is not present in the things it grounds. This is the same structural picture as the vacuum, a ground that appears as nothing but is functionally constitutive of everything. The languages are thousands of years and entire civilizations apart. The methods, early Chinese philosophical poetry, and cosmological speculation versus quantum field theory, share nothing. The architecture is the same. And now the correction that all four of these traditions require, without exception, when they are misread in the way that the popular version misreads them. It is said, in many books, in many talks, in the idiom of contemporary spirituality, that if the universe is in consciousness, if awareness is the ground of reality, then you can shape reality with your awareness, that your thoughts create your experience, that consciousness is the author of the world, that what you focus on, you become, that the universe is in your mind. Therefore, you are the author of the universe, and to change the universe, you need only change your mind. This is not what any of these traditions teach. It is the precise opposite of what they teach. Shankara, the ego, ahankara, the I-maker, is itself Maya. It is not the ground. It is among the most superficial of the appearances. The practice of Advaita is not to empower the ego, but to dissolve it. The very claim, "I am the author of the world," is the highest form of avidya, ignorance. The realization the tradition points toward is the discovery that the I, doing the claiming, was never the ground. The ground is Brahman. The ego is the snake. The rope was always there. Vasubandhu. Even the alaya vijnana is not your personal consciousness. Your personal sense of self arises from the manas. The seventh consciousness, the I-making faculty, the alaya is prior to it. What the tradition invites is not the strengthening of the personal self's reach over the world, but the recognition that the personal self is a pattern running through a field it did not create and does not control. Ibn Arabi. The cosmos exists as the mirror of the real's self-knowing. You are in the mirror. The real sees itself through you. The mirror does not author the face. The face uses the mirror. The tradition's invitation is not to become the author. It is to become a more polished mirror, more transparent, less distorting, more accurately reflecting the face that looks through you. Eckhart. The uncreated spark is not the ego. It is not the personality. It is not the you that makes choices and has preferences and wants things. It is what remains when all of that is released. Gelassenheit, the releasement, the letting go, is the practice precisely because the self that wants to author the world is the obstacle, not the instrument. The Godhead is found not by reaching, but by emptying. 4 roads, different centuries, different continents, different languages, different methods. One structural conclusion: the universe is not in your mind. If it is in any mind, it is in mind, and you are inside it, not it inside you. The path to the ground is not through asserting yourself. It is through releasing the assertion. Releasing is not failure. In each of these traditions, it is the hardest thing. Shankara's student does not release the ego by deciding to. Eckhart's listener does not achieve Gelassenheit through effort. Gaudapada's Ajativada does not arrive by accumulating arguments. The release, in each tradition, is what happens when the investigation has been followed far enough that the investigator runs out of ground to stand on. The question is not answered. The questioner is dissolved, and something remains in which neither the question nor the questioner was ever the main event. The map and the territory are not the same, but these maps, drawn from different continents by different methods over 2,000 years, arrive at the same structural picture, not because one influenced another, not because the true nature of reality is obvious to anyone who pays attention, but because the structure of the question, followed with sufficient rigor, forces a particular shape of answer. The boundary between the knower and the known, traced far enough, becomes unclear. And at the point where it becomes unclear, in the Seelengrund and in the Alaya Vijnana, and in the imaginal realm, and in Gaudapada's undivided ground, and at the edge of the von Neumann chain, what waits is not a better map. It is the recognition that the map and the territory were never two different things. What remains, in the language of physics and in the silence of the traditions alike, is a question of an unusual kind. Not what is the answer, not which road was right, but what to do with a question that, followed honestly to the end, dissolves the questioner. What does the investigation add up to? Not what it suggests, not what it implies, not what it makes possible to believe, what it actually establishes on the ground of evidence and argument and honest accounting. This question is worth sitting with before answering it, because the gap between what is established and what is suggested is precisely where the most damage is done, in popular accounts of both physics and the contemplative traditions, in the breathless claim that science and mysticism have secretly confirmed each other, in the inflation of evidence into proof and the collapse of suggestion into certainty. The investigation begun in these pages has tried to refuse that inflation at every step. It should refuse it here too, even as it settles into what has actually been built. So here is the honest inventory. What is established is this: quantum mechanics is the most accurately confirmed physical theory in the history of science. Its predictions have been tested to 12 decimal places of precision in some regimes. No experiment has contradicted it. Superposition is real. Single particles genuinely exist in multiple states simultaneously until a measurement is made. Entanglement is real. Particles separated by arbitrary distances maintain correlations that cannot be explained by any pre-existing local agreement between them. Decoherence is real. Quantum systems interacting with their environments lose their interference properties at rates that make macroscopic superpositions unobservable in practice. These are not interpretations. They are established facts, reproducible in laboratories around the world, with applications in lasers, transistors, medical imaging, and atomic clocks. What is also established, and this is equally important, equally specific, and equally undeniable, is that quantum mechanics cannot explain why any particular measurement outcome occurs. The equation that governs the evolution of quantum systems is deterministic and linear, and it never produces a single result on its own. The rule that governs what happens at measurement, the Bohr rule, the collapse postulate, is added to the theory by hand, with no derivation from the underlying mathematics, with no physical mechanism supplied. This is not a matter of interpretation. Every interpretation of quantum mechanics, Copenhagen, many worlds, GRW, cubism, Bohmian mechanics, is an attempt to answer a question that the bare formalism does not answer. The measurement problem is open. It has been open for 90 years. This too is established. There is a certain clarity that comes from naming what is established, precisely and without inflation. The solid ground turns out to be smaller than popular accounts typically admit. The open question turns out to be larger and deeper and more structurally strange than popular accounts typically acknowledge. What physics has given us is not answers, but the exact dimensions of the questions. Questions whose shape we could not even have specified before the mathematics and the experiments defined them. That is not a failure. The history of science is full of centuries-long gaps between the precise formulation of a question and its answer. The question is precisely formulated now. It was not before the work of the last century. That is itself a kind of progress. What is suggested is a quieter matter. Suggestion is not proof, and the distinction must be maintained. The von Neumann chain, the formal demonstration that the boundary between observer and observed has no natural physical placement, suggests that the question of where experience enters the physical description cannot be answered within the physical description itself. This does not prove that experience is primary. It demonstrates that the physical theory has a seam, and that the seam is in a specific location, the interface between the process of evolution and the fact of an outcome. This is a structural finding. It points towards something. It does not arrive there. The Frauchiger-Renner theorem suggests that facts, in quantum mechanics applied consistently to observers, are not observer-independent in the full classical sense. The Proietti experiment corroborates this in a specific formal sense. Together, they suggest that the notion of a single objective fact about every physical event is at minimum complicated and at maximum in tension with the formalism. Again, suggested, not proved. Wheeler's participatory universe and cubism together suggest that participation, the active engagement of a knowing agent with a physical situation, is not an incidental feature of quantum measurement, but may be structurally constitutive of it. The measurement is not just a reading, it is an act. Facts are made in the making. This is a suggestive pattern pointed at by several independent lines of evidence. It is not a conclusion, and the convergence of multiple independent contemplative traditions, Advaita's groundless ground, Yogacarra's substrate consciousness, Ibn Arabi's imaginal cosmos, Eckhart's undivided Seelengrund, Zhuangzi's dissolved dreamer, arriving independently at a structurally similar picture, suggests that the shape these investigations keep finding is not an artifact of one cultural tradition, not the reflection of a common metaphysical preference, but possibly a structural feature of inquiry itself, found by any investigation that presses the question of mind and world far enough. This too is suggestion. It is the strongest suggestion in the entire investigation. It is not proof. And here is a suggestion about suggestion. The fact that multiple independent roads arrive at a similar shape is not, by itself, evidence that the shape corresponds to anything real. Science is full of cases where intuitive patterns point the wrong way, where convergence reflects shared cognitive tendencies rather than shared insight. The history of physics is also the history of discarded intuitions that seemed obvious until they weren't. The convergence documented in these pages may be the universe showing its architecture. It may be the human mind finding its own face in the data. Both options remain on the table. The honest voice does not pretend to know which. And here is where the ground becomes genuinely dark, and the honest voice must slow. What remains unknown is not a residue to be cleaned up when the theory matures. It is not a set of technical questions waiting for better instruments. What remains unknown is structural, and it is deep, and no one knows how to answer it. This is not a failure of nerve or a gap in the literature. It is the finding. After a century of quantum mechanics and 2,000 years of contemplative philosophy pressing the same question from opposite sides, what we have is not an answer. We have the most precise possible map of where the answer would have to live, and the discovery that nothing currently standing in the space of answers is tall enough to reach it. The first open question: why does any particular outcome occur? Not why outcomes occur at all. Decoherence addresses the appearance of that. But why this one? Why, when a detector registers slit 1, is it slit 1 and not slit 2? Why, when a particle decays, does it decay now and not a microsecond earlier? Many worlds says it is because all outcomes occur. In the branching all, there is no fact of the matter about which one happened. This is the most mathematically consistent response, and it is the one most physicists find hardest to live with because it makes the question unanswerable, not answered by both happened, but dissolved by what makes you think your branch is special. The GRW modification, a theory that introduces spontaneous objective collapse into the equations, making the collapse itself a physical event rather than a measurement event, avoids the branching, but it modifies the equations and requires new parameters that have no independent motivation beyond solving this problem. Every solution has a cost. The second open question: whether consciousness plays any causal or constitutive role in physical processes. The von Neumann-Wigner interpretation proposed that it does. The mainstream rejected this. Decoherence offered a replacement, but decoherence, as has been noted, explains the appearance without explaining the deep structure. The question, does awareness participate in the constitution of physical facts, or does it only appear after the facts are made, remains technically undecided. It may be undecidable by physics. We do not know. The third open question: what consciousness is. Not what it does, not where it lives in the brain, but why there is anything it is like to be a brain at all. The philosopher David Chalmers, in the mid-1990s, named this the hard problem of consciousness, the explanatory gap between any complete physical description of neural processes and the felt quality of experience. A detailed account of how the visual cortex processes light does not explain why there is something it is like to see red. The explanation of the function leaves unexplained the experience. This gap has not been closed. It may be a pseudo-problem, a vestige of confused concepts that will dissolve under better analysis. It may be the deepest problem in all of inquiry. No one knows which. The fourth, whether the question, is the universe in a mind, is even well posed. It may require a concept of mind and a concept of universe that are defined well enough to generate a genuine yes or no. Currently, they are not. The traditions use these words with precision within their own frameworks. The physics uses different words in different frameworks, and the question of whether they are asking the same thing, or adjacent things, or entirely different things, has not been resolved. The convergence is architectural, but whether the architecture they share is the same building or two buildings that happen to have similar floor plans is not a question the convergence itself can answer. A fifth, whether time plays a role that has not yet been understood. Yakir Aharonov, the Israeli physicist who developed the two-state vector formalism, proposed that quantum events are shaped not only by boundary conditions flowing forward from the past, but also by boundary conditions flowing backward from the future. This is not metaphor. It is the formalism. Each quantum event sits at the intersection of a forward-evolving state and a backward-evolving state, and the measurement outcome depends on both. On this reading, what happened is not fully determined by what came before. It is determined in part by what is yet to come. The full structure of a physical event, in this interpretation, is not accessible from any single direction in time. Whether this is the correct interpretation of the formalism or a suggestive mathematical artifact is not yet settled. And a sixth, the deepest, what it would mean for the question to be answered. If physics one day arrived at an interpretation that required consciousness, would that be a discovery about consciousness or a discovery about physics? If the contemplative tradition's accounts of the undivided ground were someday confirmed how, by whom, by what method, would that make them science or something else? The measurement problem may ultimately dissolve, not because an answer is found, but because the category of answer turns out to be the wrong shape for this kind of question. The inquiry may have to become something other than what it is in order to go further. We do not know. This phrase has been used before in this investigation. It is used again here with different weight. Earlier, it was the weight of a specific unresolved problem. Here, it is the weight of standing at the true frontier, the place where not only the answer, but the method of answering is in question. This is not despair. It is the honest condition of anyone who has followed the question far enough to see how deep it actually goes. And there is something else in this condition that deserves notice. Every major tradition represented in this investigation, Advaita, Yogacara, the Sufi path, the way of Eckhart, proposed in its own language that arriving at genuine not knowing was itself a kind of arrival, not a failure to have arrived somewhere else, not a way station toward a better answer, an end point. The dissolving of the questioner is not incidental to these traditions. It is their declared destination. The traditions do not promise an answer to the question, what is the ground of being? They promise the dissolution of the asker into the answer, which is to say, the discovery that the question was always already arising in the answer and could not have been anywhere else. Whether this is insight or evasion is itself a question that cannot be answered by analysis. It can only be lived into or not. The investigation does not know which. There is a voice that deserves to speak before the inquiry settles. The voice that most clearly names the temptation to move too fast from the open question to the preferred answer. It is the most intellectually rigorous voice in the room, and it needs to be taken seriously. The materialist case, stated in its strongest form, is this: decoherence combined with the Everettian branching universe describes a complete world with no need for observers, no need for consciousness, no need for a privileged cut between knower and known. The appearance of a single classical world arises naturally from the universal wave functions branching. There is no fact of the matter about which branch, because all branches are equally real. The feeling of having been in one particular outcome is entirely explicable as the internal experience of one branch perspective. No mind required, just physics, running forward in time. Consciousness is a property of certain kinds of complex information processing. The explanatory gap may be real, but may be a sign that the concepts consciousness and physical process are being held apart artificially. The structural parallels between quantum physics and the contemplative traditions may be the human mind doing what it does best, finding patterns across domains, reading its own face into the structure of what it investigates, faces in clouds, constellations in chaos. The convergence is our projection, not reality's signature. Grant this its full force. It is the most intellectually coherent position held by the most rigorous investigators in the field. It is not credulous. It is not lazy. It looks at the evidence and provides an account that does not require anything beyond the physical, and then name what it requires of physics calmly, an account of the one thing it uses to do all of this work. Every argument the materialist makes, every experiment, every equation, every logical step takes place in and for awareness. The data from the Proietti experiment is data for an aware physicist. The decoherence calculation is a calculation performed by and in conscious attention. The very claim consciousness is a late product of matter is a claim formulated in consciousness. The account requires the thing it explains away. This does not refute the materialist. It marks the edge of the materialist's position. The materialist's edge is the hard problem, the inability to explain from within the physical description why physical processes are accompanied by inner experience at all. The idealist's edge is the complementary problem, the inability to explain from within a single undivided awareness how the appearance of a divided and structured world arises. Both edges are real. Both are unresolved. The materialist and the idealist are standing in honest ignorance at the same frontier, facing different directions. Neither has crossed it. Neither can honestly claim to have crossed it. Both sides are selling something. The materialist sells the comfort of a world that needs no witness. The idealist sells the comfort of a world that is warm at the core. The honest position is neither, and it is colder than both. We do not know. The question is open. The investigation is ongoing. The investigators are standing at the edge, looking over into the dark, and neither their equations nor their contemplative disciplines have returned with a report from the other side. This is the ground, not the ground of an answer, the ground that the question rests on. There is a particular quality to standing here that is worth naming. It is not the frustration of a problem not yet solved. It is closer to the quality of a room at the edge of sleep, the sense that the habitual machinery of resolution has loosened, that the urgency of finding the answer has quieted, and what remains is the question itself, alive, without the anxiety of needing to close it. The question is not a problem. The question is what the inquiry has been building toward, not the elimination of mystery, but the honest, awake, unconsoled standing in the middle of it. Most of what has been said tonight has been preparation for this standing. The standing itself has no content. It is simply what is left when everything that can be said has been said. The room you are in is quiet, or close to quiet. The body that has been carrying these ideas through the night is heavy. Whatever is still awake, the part that has followed this from a physicist named de Broglie in Paris in 1924, through to Eckhart's condemned sermon in Erfurt and Zhuangzi's butterfly and the threshold of the closed laboratory where Wigner's friend holds a measurement in the dark. That part has been working in a very specific faculty of awareness, the faculty that can follow an argument. That tracks the named physicist, the named text, the named century, the faculty that is currently still reading, and beneath that faculty, quieter, not absent, is something that has been present the entire time, not tracking, not following, just present, the ground condition for the tracking, the quiet floor on which the argument has been walking. You do not have to look for it. You cannot look for it. It is what is doing the looking. You can doubt many things. You can doubt the chair in the empty room. You can doubt whether the electron went through slit 1 or slit 2. You can doubt whether the universe is in a mind. You can doubt whether the traditions were pointing at something real or constructing something useful. All of this is doubtable, And the honest investigation has been offering you reasons to hold each of these questions open. You cannot doubt that this is being experienced, not what it means, not whether it is real in the philosophical sense, just the raw fact that something is present here, that experience is happening, that something appears, that the room and the words and the quiet weight of the body are occurring in something. Whatever that something is, and the traditions and the physics both have things to say about what it might be, and none of them are certain. The something itself is not in doubt. You cannot coherently deny the awareness in which the denial would arise. This is the one thing that remains when everything else is questioned. The traditions were not wrong to call this the starting point. Shankara called it the self-luminous witness, the awareness that illuminates all experience without being illuminated by anything else. Eckhart called it the uncreated spark. The Yogacara teachers called it, in the most refined formulations, the clear light of mind. Not a metaphor for intelligence, but a description of the quality of awareness itself, prior to any content. Ibn Arabi called it the innermost reality from which the real looks out at itself through creation. These are different languages. The pointing is the same. Each tradition arrived, by its own road, at the one thing that cannot be removed from the investigation, because it is the condition of there being an investigation at all. The investigation of the outer world, the electron, the detector, the von Neumann chain, arrived at this starting point from the outside, after 100 years of rigor and $1 trillion of equipment. The contemplatives arrived at it from the inside, without the equipment, by going in the direction that physics avoids. The arrival is not the same. The starting point is. The question that cannot be answered is not, is the universe in a mind? That question may be, as noted, not yet well posed enough to answer. The question is simpler and more immediate. It is, what is this? The field of awareness in which the universe appears, including the universe, as described by the physics. What is this? Where does it begin? What is its edge? Whether it ends at the skull, or whether it is the ground in which the skull, and everything outside the skull, is appearing. This is the question that physics has mapped the shape of without answering, and that the traditions have spent millennia approaching from the inside without ever fully arriving. The approach continues. The chair is still in the dark room. It has been there since the first sentence. Everything that has come since, the de Broglie wavelength and the Born rule and the van Neumann chain and the butterfly and the hidden treasure and the eye through which God sees, has circled around the fact of the chair, sitting in the dark, neither proven to exist nor proven to dissolve when the room empties. The question was there before it had a physics. It will still be there when the physics changes, as the physics will. The investigation that has been conducted here is one of the more honest surveys of what is known and what is not. It is not complete. It cannot be. The full 20 centuries of contemplative investigation cannot be compressed into a single sitting. The full 100 years of quantum foundations cannot be summarized in a night. What has been offered is a shape, the shape of the question, visible from physics and from the tradition simultaneously, more clearly than it can be seen from either side alone. The shape does not answer the question. It does perhaps establish that the question is real, that it is not a category error, that it is not answered by the physics and not answered by the traditions and not answered by the combination of both, and that this persistent unanswerability is itself information about the depth of what is being asked. Something holds the chair there. The investigation has not named it. The traditions have offered names. The physics has offered structures. Neither the names nor the structures are the thing. The thing remains, quiet in the dark, behind every name and every structure, holding everything that appears in it, without moving, without effort, without the slightest sign of fatigue. And so the chair stays where it is, in the dark, in the empty room, held in being by an attention that does not blink, that has no name in any language and the same name in all of them, and that has, perhaps, been wearing your face the whole time, looking out through one slow pair of closing eyes at a world it dreamed and called another.